Alright, hi guys. This will be our last video for the week before we get into our quiz and then the rest of the chapter next week. So we're going to look at perimeters and area of similar figures today. So we've already been exposed to similar figures, meaning we can write a similarity ratio and do all kinds of stuff. So we're going to apply our ratios to perimeters and areas today. So we have a theorem that states that, hey, if two polygons are similar with the lengths of corresponding sides in the ratio of A to B, then there's two things that hold true. If the sides have a ratio of A to B, corresponding sides, then the ratio of their whole perimeters, meaning all their sides summed together, is also A to B. So it's going to be same as one side. We also know then that the ratio of the areas is squares. So we're going to have this cool little ratio of A squared to B squared. So if I can find the ratio of the perimeter or the ratio of one of the sets of sides, I can figure out what the ratio of the areas are as well. So let's take a look at an example. In the diagram, triangle ABC is similar to triangle DEF. Find the indicated ratio. So we want the ratio shaded to unshaded. So I want shaded on top numerator to unshaded denominator of the perimeters. So we know the ratio of the perimeters is going to be the exact same thing as the ratio of the sides. So my perimeter ratio is corresponding side DF. We just need to make sure DF is first and last in the naming, corresponds to AC, and AC is up here, so it does. So I know the ratio is 9 to 6, which simplifies to 3 over 2, or can be written as 3 to 2. We want to find the ratio of the areas. We know the areas are the square of the perimeters. So if I have a 3 squared to 2 squared, my area ratio is, what is that, 9 over 4, or 9 to 4. Okay, so these are pretty easy. What we need to be able to do is go back and forth. So if I know my area ratio, I need to be able to get to the perimeter ratio by taking the square root, the inverse operation. So instead of squaring it, we're going to take the square root. And really, that's all we're going to do, set up some ratios in application problems. But other than that, that's it for the lecture today. So let's apply some of this. You buy 2 rectangular pieces of aluminum window screening. One is 15 feet long and costs $135. So I'm just going to quickly draw a picture. I know I have 15 feet and it costs $135 to buy that rectangular piece of aluminum. The other is similar, so they're telling us there's a similarity ratio in shape and is 20 feet long. So I know that's 20 feet long. The screen is sold by the square foot. What is the cost of the longer roll? So I can use my ratio of sides to determine what then the ratio of the cost of the rolls are. So we know that 20 is to 15, which is reduced to 4 over 3 is my perimeter ratio. So when I'm talking area though, so when I'm looking at costs, that's per square foot. So 15 costs $135, so for the total, so that's by square foot. So we want to figure out how much this one's going to cost. So if I take my 4/3 area here, 4/3 perimeter ratio, and square it, I'm going to get the area ratio, which is equal to 16 over 9. 4 squared is 16, 3 squared is 9. So 16 is to 9 as x. 16 is to 9 as x. So I'm looking for the cost here is to 135. Cross multiply to solve for x, I get x is equal to 240. So I know that my cost of the larger roll is $240. Alright, you should have a couple that you're going to try here. So start by finding your perimeter ratio and then find your area ratio. When you're done, check your answers. Okay, there are your answers for your practice problems. If you didn't get them right, take a look and see how you do them, and then come back and ask questions tomorrow when I see you. Alright, let's see what we got here. Let's try another example. I have a billboard, a large rectangular billboard is 12 feet high and 27 feet long. So I know it's 12 feet high and 27 feet long. A smaller billboard is similar to the large one, and the area of the smaller one is 144 square feet. So I know I have a smaller one shaped similarly. The area for this one is 144 square feet. Find the height of the smaller billboard. So the height I'm going to call H is what I'm looking for. Right now I don't have anything talking about area to area, or I don't know any of these sides, so I can't set up a perimeter ratio yet. So I need to stop and think, okay, what can I set? I don't know any of these sides, so I can't go figure out what the perimeter is. But I know the area of the smaller billboard, and I can find the area of the larger billboard using our area formula. It's a rectangle, so I know area equals base times height, which means I have 12 times 27. So I know that the area is 324. So I know that the area of this larger billboard is 324 square feet. Now I can set up a ratio. I have an area to an area, so why don't we set up the ratio of area? So I'm going to set up area ratio is 324 to 144. And if I simplify that, I should be able to do that mentally or work my way through reducing those. I also have my tool for the math frac. 324 divided by 144, and you hit enter, gives you a decimal. To convert that decimal back in math bracket, and it reduces it for you down to 9/4. So the ratio, the area ratio is 9:4. Now that I know the area ratio, I can work my way back about setting up a ratio for the side lengths. But I need to remember, the area is the square. Ratio is square of the perimeter. So my inverse operation would be to take the square root to find some side lengths. So in order to do the perimeter ratio, I have the square root of 9 over the square root of 4, which is equal to 3/2. Now that I know what the perimeter ratio is, it's also the side ratio. So I know 3:2 as, and set up your pieces. 3 is my larger, so 3:2 as 12 is to H. Once I have my proportion, I can solve for H by cross multiplying, and I get H is equal to 8. So I know my height is 8 feet. Alright, let's just do these U tries together, and let's talk about them. Suppose the area of the smaller board is billboard is 225. So instead, I still have a big billboard of 324, 27, and 12. And they're changing it up, and the smaller one, instead of being 144, is 225. So my process is going to be the same. I still have to set up my area ratio. Is the 324 is to 225. Simplify that with my calculator, and I end up getting 36/25. Since I'm looking for the height, I need to first figure out what the ratio of the perimeter is by taking the square root of the area ratio. So the square root of 36 over the square root of 25, which means I have 6/5. Now I know what the ratio is, I can set up my proportion to figure out what it is. So 6:5 as 12:27. 12:H, sorry. That makes more sense because we're solving. So 6:5 is my perimeter ratio, is 12:H. Okay. Then we cross multiply to solve for H, and we get H is equal to 10. So my height, when my area is 225 square feet, my height is 10 feet. All right, let's try the next one. So we have a stop sign. A stop sign rug, it's actually a rug that looks like a stop sign, is a regular octagon. So we know we're going to have 8-sided figure. And ideally, those will all be the same length, same angles. Each side is 2 feet. 2 feet. And the area is approximately 19.3. So I'm going to stick my area in here. Feet squared. You make a stop sign mat with a perimeter of 72 inches. Find the area of the mat. So I made a mat replica of that stop sign. And the perimeter equals 72 inches. So this should clue us in that, hey, we got feet and we got inches going on here. We got to do some conversion to figure out what's happening. It says find the area of the mat to the nearest 1/10 of a square inch. So we need to find this area. So I'm going to call this X because that's the area I'm looking for. And what else do we need to do? I have an area to an area, but I don't know the area, so I can't set up a proportion there. I have a side length to a perimeter. Because this is a regular octagon, we can figure out what all the sides are so that we can set up a ratio between the side to the side or the perimeter to the perimeter. Or vice versa, I can convert this to the whole perimeter. So if we go 8-sided figure, and they're 2 feet each. So I know my perimeter for this one is going to equal 8 times 2, which is equal to 16 feet. I still have an issue because I have 16 feet and I have inches here. So I need to convert them. But I know I have a perimeter ratio now. And it is 16 feet is to 72 inches. In order to go one versus the other, if I take 72 and divide it by 12, I get 6. Or if I take 16 and multiply it by 12. So I'm going to convert to inches because ultimately we need to be in inches because this is the area it's looking for. So I'm going to multiply this one by 12 over 1, and I end up with 192 over 72. In my calculator, that is going to math frac down to 8 to 3. Now that I know what my perimeter ratio is, I can use that to figure out what my area is. So my area ratio is the square of the perimeter. So I know I'm going to have 8 squared over 3 squared, which is equal to 64 over 9. And if I math frac that or take a look at it, and that 3 doesn't go in here and 9 doesn't go in here, so that's a simplified. So I know that 64 is to 9 as 19.3 is to X. Because this is feet, that means I'm going to have to convert again once I get past this back into inches, so I have the total. So I know that X is equal to 9 times 19.3 divided by 64. I get X is equal to 2.714 feet. I want to get that into inches, but I want it in square inches. So I need to take 2.714 over 1 times 12, that's 1 foot, but are getting me into inches, so this is feet to inches, but I need it 12 squared, because I need inches squared. And I'm going to divide out this feet squared that I had below, and that's going to cancel out my feet squared. So I'm going to multiply by 144, and I get 390.8 inches squared is the area of my smaller mat. And that's approximate area.
Please come to the main reception desk. Brianna Hovis, please come to the main reception desk.
All right, 4 and 5 are for you to try, so go ahead and pause the video, give those a try, and come back and check your answers. Okay, there are your answers for numbers 4 and 5. Let me know if you have any questions when you come in tomorrow. And let's take a look at the last couple. So this will be a real quick lecture today. It says complete the table of ratios for similar polygons. So I know they're similar. And I have some data. I know that the side lengths ratio is going to equal the ratio of the perimeters. But the area ratio is going to be the square, so perimeter squared. So I can work my way back and forth among these numbers. So if 5:8 is my ratio for the side lengths, I know 5:8 is the ratio for my perimeter, and I know I have to square these, so 5 squared is to 8 squared, which is equal to 25 is to 64. They gave me the perimeter ratio of 4:7. So I know the side ratio is going to be the same, and I know I have to square to get to the area ratio. 16 is to 49. You want to make sure you simplify these as you go. Here they gave me the area. It's already been squared. So if I want to figure out where it was before it was squared, I have to take the square root. So this is the square root of 169 as the square root of 36. So this is equal to square root of 169, that's 13 is to 6. And I know perimeters are the same as side length, so 13 is to 6. So you're going to need to be able to work back and forth each way. And here's when we have to simplify it. If I have 66 is to 18, then 6 goes into 66 and 6 goes into 18, so I end up with 11 is to 3. My sides and my perimeters are the same ratio. And my area is the square of the perimeter or the side. So 11 squared is 121 is to 3 squared, which is 9. Okay, let's take a look at some given information. So we want to find xy, it says. Xy is this side length here. Its corresponding is this side here. So I can't set up a proportion with my sides, but they gave me the area and the area. So I can start with an area ratio of EF. This one starts first, so I'm going to put this in the numerator. 168 over 378. Luckily, our math frac button has us where we don't have to think, and we end up with 4 over 9 is the area ratio. Since I have the area ratio, I must have squared something. So in order to get back to what that something was, I need to take the square root. So my perimeter ratio is equal to the square root of the area ratio. Alright, sorry about that interruption. Okay, so we know that the perimeter ratio is equal to the square root of the area ratio, so that means I need the square root of 4 over the square root of 9. Which is equal to 2 is to 3. Now that I know what my side or my perimeter ratio is, I can go write a proportion so that I can find the value of that. So I know 2 is to 3 as 8 is to segment xy. When I solve for xy, 8 times 3 is 24, divided by 2, I know that xy is equal to 12 centimeters. Okay, you've got one to try, and then I will see you in class. Okay, so that's the answer that I got for the length of xy in this case. Reasonableness checks in, saying, hey, that's 15, and that's 5. That makes sense. We'll go from there. Thanks.